Yes, screen is available.
Yes, sir.
Okay. So in the previous class, we were discussing about some of the important topic in the fourth and fifth model. So in that we discussed the very present hot topic. You can call it as the quantum computer. So quantum computer uses mostly the molecules, atom, proton, neutron, electrons. So as like a normal computer, it uses only the binary number called as a 0 1. So uses the binary number 0 and 1. Okay, so for example, you can take 0. So 0 maximum it can move only either if it is a 1 you can take, it can move upward direction, or it can move the downward direction. Okay, so this is the problem with the binary computer. Either you can say it is a up or it is a down. So up you are taking it as a 1, so it is a 0. Whereas in the quantum molecule, so what happens? Either it can move upward direction, move right, left, downward, diagonally. So very powerful. So quantum molecule, it is very powerful. It is not like either the developer can use in order to execute the program. So you need to maximum he can use either 0 or 1. Okay, so program consists of the thousand zeros and one. You need to arrange these zeros and ones. So it is consuming lot of time. Whereas in the case of the this quantum computer, it is its position is it is a superposition. Okay, it is a superposition. It is like a it is like a the binary number is like it is working like a normal human being. It is working like a normal human being. Okay, normal human being, what happens? Maximum he can walk, run. Whereas it is behaving like a Superman. I think you might have seen the movie, Superman movie. He can walk, run, jump, fly, so like that. But this because of this superposition, so the quantum bits are available instead of the binary bit. The quantum bits are available. Maybe it is available like this: 1011 00. So here in the binary maximum, you can have the 0 or 1. So you can have this group of the this binary number. You can call it as a qubit, or you can call it as a the quantum bits. The quantum bits. Due to this features, the developer can easily develop by making use of the qubit. They can easily develop easily, fastly, effectively, efficiently develop the programs. Okay, so but the disadvantage of this quantum bit is it act like a superposition when it is not observed. So if it is not observed, it is acting as like a superposition. When it is observed, it is behaving like a the binary number. Okay, so observed means, for example, if you are supplying the electrical voltage to the quantum molecule, so once it get the electrical supply, so it is acting like either it can move, the quantum molecule can move upward, or the quantum molecule can move the downward. Okay, either it can move upward or downward. So upward and downward is almost like the binary numbers. Okay, so the scientists are working, they want to make use of this feature of the quantum molecule in the superposition. So for that, so it requires, IBM and Intel already they are making use of the superpositions features of the quantum molecule. But in order to maintain this superposition of the quantum molecule, So it is very expense. Why it is expense? The computer which is made up of the quantum molecule, they should operate always in the 0 degree centigrade or less than 0 degree centigrade. If it is maintained in the 0 degree centigrade, no doubt it consumes more power. It is not economical. That is what most of the computer whatever we are using, they are only the binary computers, okay, digital computers. So lot of research is going on in the quantum computers. So once the quantum computer comes into the picture, okay, so the execution will be very fast. For example, the binary computer taking the 10 days to execute one job in the company, so the quantum computer will finish it maybe in the half day, in the half day. So this is how the difference between, you can find the difference between the quantum computer and the binary computer, or you can call it as a digital computer. So why it is a fast? It is like a Superman. Okay, the normal computer are like a human being. Okay, so this is what the quantum computer. So next we'll discuss the conversion equivalency between the PDA and the equivalency between CFG and PDA. Very important topic. Whenever you have doubt, you please stop me. So we are finding equivalency between CFG and the PDA, context-free grammar and push-down automata. Okay. So CFG is having its own PDA, and whatever the problem in the form of PDA, it is having its own CFG. We will see when the CFG is given how to find out the equivalency in the form of PDA. Okay. For example, if the CFG is like this, so question will ask always CFG to the PDA. Okay. PDA to the CFG, only one or two times question has been asked. CFG to PDA, most of the time question will be on CFG to PDA. That means the variables are given, you need to convert. Variables are given, you need to convert into the transition functions, because the PDA uses the transition functions. So hence we are converting the variable into the transition function. So simple example I'll take. For example, you can take the CFG. CFG is always in the form of production. S describes AB. S describes AB. Okay. So to convert this into the transition function, that is what you can call it as a PDA. So this is a CFG. So you need to convert this CFG into the PDA. PDA means the transition function. CFG means the production. So how to convert this CFG into the transition function? So what will be available in the transition function of the PDA? So in the case of the PDA, you can have the Q sigma is there. Then you can have the stack symbols. What is the output? The output is a, so the Q into the stack symbols. The Q into the stack symbols. Multiple symbols is represented with the tau, and a single symbol of the stack is represented with the tau. Tau star is multiple, tau is a single. So from this feature, you need to find out the equivalent, that is a delta function. So for this, the delta function is, you can derive delta as, you can take any PDA you take, initial state will be there, you can write the initial state. Okay, so initial state, then sigma. So from this, what are the sigmas are there? So sigma is it is a sigma is equal to in the form of 0, 1, or English small letters. Hence sigma. So sigma is, it is a, from this CFG, sigma is, it is a. Okay. Then Z naught. So generally, the first one will be the starting symbol of the stack. So tau is the always you can go through the PDA. So first transition functions, you can find the Z naught, where Z naught is the starting symbol of the stack, or you can call it as a initial symbol of the stack. So Z naught is what? So it is a initial symbol, initial symbol in the stack, symbol in the stack. Okay, or you can call it as a the starting symbol of the stack. You can call it as a, so Z naught is you can call it as a, it is a starting symbol of the Z naught. You can write Z naught as a either initial or starting symbol in the stack, starting symbol in the stack. Okay. Hence, in this, we don't have the Z naught. Okay. But the starting symbol is there, that is a S. Okay. In the CFG, when it come for the PDA, so this will become the starting symbol of the stack. Okay, Z naught is a starting symbol of the stack. Okay, and S is the starting symbol of the CFG. Hence both are starting. When productions are given, instead of the Z naught you can take S. So therefore Q naught AS is equal to, you can write output as a Q naught, output is a Q naught, and the stack symbols are AB, stack symbols are AB. This is how we convert the production into the what you can call it as a, sorry, the CFG into the production. So these are the productions are the basic building block of the what you can call it as a PDA. Generally at the end we switch, so from Q naught, epsilon is there, stack is empty, it is pointing to Z naught. According to the CFG, starting symbol is S, in the PD it is a Z naught, hence equivalent symbol in the CFG is a S in place of the Z naught. When this is the case, generally in the PDA what we are going to do, Q naught step is empty and the stack is pointing to the initial symbol. So we are changing the initial state to the final state. It is a Q1 to the, so it is a Q1 to the Z naught. Like that here also, in the conversion, even though this production is not there, CFG is not there. So for this CFG is not there, but we know Q naught reads the empty symbol and the starting symbol of the CFG. It is going to change the state from the Q1 to the S, Q1 to the S, and it halts. Hence, for example, if the productions are given S describes AB, its equivalent transition functions in the PDA is one is this. This is the first one. One is this. One is this. This is the first one. This is the first one transition function, and this is the second one transition function. Okay. For example, you can find. I'll show you. If the production is, for example, you can take. Yes, describes. Okay. So you can take the production. Yes, describes ASB, ASB bar BSA. Okay. So such a productions, such a CFG, it is very difficult to convert into the PDA. Okay. CFGs are given. CFGs are given. It is in the form of production. PDA, it is in the form of transition function. If such a CFG are there, it is very difficult to convert the transition function. Okay, so it has to fulfill the condition of the Greback normal form. The productions on the right hand side, so always follow the Greback normal form. What the Greback normal form says, so it is a terminal followed by only variables. But here after variable, we are finding one terminal. Okay, so this is not in the Greback normal form. So please make a note down, take the pen and paper. So to convert any CFG into the transition function, that is a PDA, or to convert any production into the transition function of the PDA, the production should be in the form of Greback normal form only, and they are a desired one. There should not be any epsilon production, there should not be any useless symbol, there should not be any unit production. So productions are there, undesired productions are there, you need to convert into desired. If they are not in the Greback normal form, you need to convert into the Greback normal form before finding the equivalence of the PDA. Okay, so what I am going to do, so first I will convert this production into the Greback normal form. It is not in the Greback normal form. Now I am going to convert them into the GNF, Greback normal form. So in the Greback normal form, so terminal is followed by, so always the variable or variables. Now I'll replace B by AB, and in this case BS describes the terminal A by the variable capital A base A. As I told, so whenever the terminals are there, replace it by the variable A only, make the base as the terminal. Make the base as a terminal. Hence, now all these productions are in the Greback normal form. Okay, what for you replaced AB? AB is replaced for the terminal B. What for you replaced AA? So this AA is replaced. You compare this AA with this one. So BS is there. It is a similar one. Compare, only difference is, so you can find AA is replaced as a small a. Don't write vice versa. Okay, don't write like this. A describes AA. So it is a wrong. Always variable only have the definition. So if you write like this, the terminal is describing AA, that is wrong only. So this is correct. Always on the left hand side variables are coming. On the right hand side terminal as well as variables will come. But see that on the left hand side of the production always variable. Now once see, this is also in the GNF, either only terminal on the right hand side, hence this is a terminal on the right hand side, this is in the GNF, terminal on the right hand side, so this is also in the GNF, so this is already converted. Now once you get the production in the form of Greback normal form, you can convert them into the transition function. So it is Q is there in the PDA, so you need to take this Q naught. Okay, so Q naught, then sigma is there in the transition function. We have the Q, sigma, then stack symbol. So it is going to take you to the one state of the PDA and the stack symbols. So from this, S describes, see, S describes ASB, S describes A, S, AB, AS, AB. So from this, the sigma is, it is a. So sigma is a terminal, so it is a. And the stack symbol is, it is the Z naught is there in the PDA, but in the CFG given, so in place of the Z naught, you can consider, because S in the CFG, it is equivalent to the Z naught in the PDA, where Z naught is, you know, it is the initial symbol on the stack, or you can call it as a starting symbol of the stack. Hence, we do not have the Z naught. In place of Z naught, you can take the S. So Q naught, so this is S. So from where I have taken S, so S is taken from this. Okay, stack symbol. Generally, it will be Z naught in the PDA, but CFG Z naught is equal to S. Hence, Z naught is not given in the production. In place of the Z naught, you can consider it as a S. So therefore, the production is Q naught A comma S is equal to, so Q is, it is a Q naught. Q is a Q naught. Tau star is, so these are the tau star. These are the tau star. Tau star is, it is a S into AB. So S into AB, these are all called as a tau star. These are all called as a tau star. Okay, next, S describes BS, A is there. So S is defined as a, S is defined as a BS AA, BS AA. Therefore, equivalent transition function is, it is a delta of Q naught, sigma is now B. So terminal, sigma means it is a B. So this one is a sigma. You can see here, this is the sigma in the transition function. So from this CFG, the sigma will be the B, and Z naught is, it is a starting symbol. So Z naught is S. So this you can write, it is equal to Q naught into the stack symbols. Stack symbols are SAA. This is how we convert the production. S describes or defines B, small b, capital S, and followed by the variable A base A. Okay. Next, so this is also in the form of CFG, that is AB describes. So AB describes B. This is also in the form of CFG. So hence you can write here. So it is a delta of Q naught. Okay, Q naught. Next, so Q naught, terminal is B, sigma is B, then stack symbol. So stack symbol you can write it as a AB, which describes. So it is equal to Q naught. Stack symbols are not there, so you can write epsilon. You can write epsilon. So in this, the two stack symbols were there in the production. That is what I have taken SAA. But here in this case, no terminal, no variables are followed the terminal. But this is in the form of Greback normal form. You can write Q naught B, the stack symbol. So right hand sides are all becomes the stack symbols. So it is a AB Q naught epsilon. So next to variable is, it is a AA describes AA describes A. For this, the transition function is, it is a Q naught AAA. Q naught AAA, where AA is the stack symbol. Hence, it is equal to Q naught comma epsilon. And the last one is, it is a delta of, so Q naught epsilon, starting symbol S, that is Z naught will be there. Generally in the PDA, in place of the S, in the CFG, S is equal to Z naught. Hence, in the problem, S is given instead of the Z naught. You can consider either Z naught or S. So it is a Q naught, sorry, it is a Q1, because both are empty. Okay, so it is equal to Q1, and the finally it is a yes. Finally, it is a yes. Generally, we write when Q naught reads empty string and the Z naught. Generally, we are writing like this: Q1 Z naught, but the Z naught is not there. So tape is empty, and starting symbol of the production is there. So state you can change it to the Q1 and S. This is how we convert all the productions into the transition functions. These are the basic building block of the PDA. These are the basic building of the PDA. Very important questions will be there. Productions are given. You need to convert these productions into the transition functions. And the next one is transition functions are given. You need to convert into the production. For example, you can find the transition function like a delta of, okay, transition function Q naught, it is epsilon Z naught. Okay, or you can take this, the first one you can take, the first one q naught, this transition function you can take q naught as is equal to q naught ab. I'll take this transition function, q naught delta of, in the case of the pda to cfg. One minute, it gets stuck. In the case of the pda to cfg, pda to cfg, transition functions are given, deltas are given, you need to convert into the variables. You need to convert into the variables. And this equivalency PDA to the CFG, we do not have any rules to convert PDA into the CFG. So it is a blind method. That is what it is called as a. So there is a no particular rules we are using to convert PDA to the CFG. So such a method we can call it as a blind method. For example, your transition function, that is delta is given as a q naught a s, q naught a s is equal to q naught ab, q naught ab. This is the transition function is given. So in such a case, what you can do, so you need to convert these transition functions into the variable. So first, what you can do, you write the starting production. Starting production is written as a blind method, I am telling. So starting production is written as a, it is a Q naught, okay. So terminal and Q. Terminal, that is, you can take it as a, here it is a terminal is A. So Q naught A, it is a Q. Q naught A Q. So generally in the PDA or in the CFG, in the PDA you can find two states. One state will be, it is a Q naught. It is a Q naught. Okay. So one state will be Q naught, and this A is A as it is. One time you can substitute this as a Q naught, and the second time you can substitute this as a, so Q naught A, so Q1. So then Q is one time you can write it as a Q naught, and in the PDA maximum you can find Q naught as well as the Q1. Therefore, one time for the starting symbol S, you can replace one time it as a Q naught and second time it as a Q1. Hence, for the starting variable S, you can find the two production. One production is this, and this is the second productions. Okay. For example, I will show you how to convert. It is a blind method. So variable is always, see, it is a variable goes like this. So this is a variable for this transition production. Sorry, it is what you can call it as a this transition function. The production will be like this. The variable you can write it as a, it is a q naught. Okay, q naught yes. So this yes you need to write. So here it is a yes. It is a yes only. It is a yes, not a. So q naught. So this q naught you can write here. Then yes. So this is a yes. Yes, on the right hand side of the uh, transition function, then you can write q naught. What, from where I bought this q naught? This q naught is this one. Okay, so this will be one variable. This will be one variable on the right hand side. So terminal will be there in the production. Terminal is, it is a, this one terminal only. You can take terminal A followed by, you can write q naught. Q naught. So then q naught, it is a q, one variable, and the second variable is q. So last one is again it is a q naught. Why it is a q naught? Because so this is also q naught. The first is a Q naught, and so on the right hand side, it is a Q naught, and this one is last is the Q naught, so it is a Q naught. Okay, and the variable A and B are there. First time you can take the variable A, second time you can take the variable B. So this B is written here. This B is written here, and this A is so written here. Okay, so for this transition function, I am going to write the production one more time. So it is first you can write Q naught and the variable on the left hand side. So variable on the left hand side is it is a S. Then this Q naught all together acts like a one variable. This is the one variable. If you are converting PDA to the transition function, so in the PDA production, so in the PDA transition functions are there, we need to convert these transition functions into the productions. Productions, it consists of only variable. This is the one variable. This is the one variable of the production on the left hand side. Left hand side. Okay, right hand side always Greback normal form. So terminal followed by variable. This is the second variable and this is the third variable. For example, in the Greback normal form, S describes terminal followed by X and Y is there, no? Like that. So on the right hand side, so terminal is, it is a in the production, in the transition function, the terminal is A. So if B is given, you can write B here. So A is given, that's what. On the right hand side, it is always terminal. So from the transition function, we can find only one terminal that you can write here. Terminal followed by number of variables. So one variable is, it is a Q naught. How about Q naught? This Q naught is here. This Q naught. Then last one is a Q in one variable. Next one is a Q, and last one is a Q naught. For example, you can take this Q naught has bought here. This Q naught has bought here. If it is a Q1, so I would have written here Q1. But it is a Q naught, both the sides, it is a Q naught only. First and the last state is a Q naught in the left hand side of the variable. Hence, you can write the first as a Q naught, last as a Q naught. Okay. Next, in between this, generally beginning and end of the variable is a state only. In between, stack symbols are there. In the production, one stack symbol is, it is a. You can write here A, and other one is the B. Okay. This is how we convert the transition function into the productions. Generally, how do you write? So this you can write particularly. So it is equal to Q naught. Sorry, Q naught. Then A. One time you can replace this Q as a Q naught. Hence, this Q is replaced as a Q naught. This Q is also, you need to replace it as a Q naught. B, then Q naught as it is. This Q naught as it is. Second time you can replace in the PDA. You can find Q naught as well as Q1 most of the PDA. Second time you can replace this as a Q naught A, Q as a capital Q as a. Second time you can replace it by Q1. So here you replace it Q as a Q1. This Q you need to replace it as a Q1 only. Q1 B Q naught. This is how we convert the production into the the transition function into the production. For example, I can take one more example. One more example. Transition functions are given. Delta of Q naught epsilon Z naught is equal to Q1 is equal to Q1 Z naught. Okay, so how do you convert this into the production? So production you can write. So this Q naught here, this Q naught here. Okay, this q1 here, this q1 you can write in the last, this q1. Now q1 has bought, and stack symbol is, it is a z naught. Stack symbol you can take in between these two state, it is a z naught. Okay, so describes as a, so terminal, so terminal is not there, so epsilon is here, hence it is a q naught. Okay, it is a, it is not a q naught, it is not a q naught, it is described as a epsilon, it is described as a epsilon. Okay, for example, if the production is given like this, delta of, productions are given, delta of, okay, q naught, huh? X, q naught x, right? So r q naught, terminal a, z naught, z naught is equal to q naught z naught, q naught z naught. Transition functions given like this. In such a case, what you can do, if single variable is there on the right hand side, on the right hand side single variable is there, you are really lucky, you can easily convert it. So if it is a, for example, assume that this is the q2, if this is the q2, so variables converted like this, q naught as it is, this q naught as it is, last one is here, it is a q2 is there, so therefore it is a q2, therefore it is a q2, and z naught is this, z naught is this, z naught. Okay, so this is equal to, so A terminal, give back normal form followed, terminal always followed by variable. Hence, in this production, the terminal is A only. You can write here in the PDA also. You can write A. So stack symbol is Z naught. So only A Z naught. Single symbol, single variable is there on the right hand side, or epsilon is there, the productions are very simple. If two variables are there, for example, you can take delta of q naught b z naught is equal to q naught. Okay, q naught, you can take a b c, a b c. So for this, the productions are, so it is, first one is, you can write first one as, so first one as, it is q naught, q naught z naught. So you write q naught here, this z naught here, then q naught, brought this q naught to the q naught. This is equal to terminal, terminal is, it is a b. So in the production, sorry, in the transition function, only you can find the terminal is, it is a b. Hence, on the right hand side of the production, terminal should be there in the Greback normal form. Okay, so three variables are there now. It is a, you write, it is a q naught. Okay, then the, it is a q, it is a q. Okay, next three variables are there, q, okay, q followed by, it is a, this is a, this is a, now this will be b. Okay, next it is a q, it is a q, next q c, hence last one is q1. So last one is this q1 or this q1, you need to bring here. Okay, so therefore generally q will be, one time it is a q naught, so second time it is a q1. You can, three variables are there, you can write like this, q naught a q, the first one is as it is, the first one only, the first one is as it is, first one, the last one is the last one, this one, last one. Okay, so one time you replace q by q naught, so second time you replace q by q1. So here also first time if you are replacing q by q naught, here also q by q naught. Second time it is a q1. Like that you can get two more productions. This is how we convert the PDA into the PDA into the CFG. Okay, it is a blind method. The PDA to the CFG is a blind method. That's what most of the time you will not find questions on the PDA to the CFG, but questions will be there on CFG to PDA. So CFG to PDA. So in this productions are given, you need to convert into the transition functions. Okay, this is regarding equivalency of the CFG and PDA. So please listen to me. CFG to PDA. So some rules are there in order to convert the production into the transition function. When transition functions are given, it is a blind method. There is a no rules to convert the transition function to the CFG. Hence, it is almost like a trial and error. So trial and error method. That's what most of the time question are not there. But bad luck is there. You may have the questions on this conversion from what you can call it as a PDA to the CFG. Okay, so this is regarding equivalency. The next one is, as I told, questions may be asked. The varieties of the questions may be asked on the DFA, design DFA. For example, if the language L is given, L is equal to W, where W is W mod 3 is equal to, so W mod 2, W mod 2 over the alphabet, alphabet mn, over the alphabet sigma is equal to m comma n whole star. Okay, so you need to describe the language. So language, what it is telling, so W mod 3 it should be equal to W mod 2. What are the strings you can expect? If this is the case, what are the strings which are made up of m and n? So for example, you are taking neither m or nor n in order to form the string W. So it will be 0. 0 mod 3 is equal to 0 mod 2. Okay, 0 mod 3 is a 0. Hence, 0 is there. Generally, we represent empty. In mathematics, 0 are the empty, whereas in the finite automata, epsilon is the empty. Epsilon is the empty. Okay. Next, you can take only one symbol. W as a M. W as a M. M means 1. M means 1. Okay. 1 mod 3 is what? 1 mod 3 is 1. And M means 1. 1 mod 2 is also 1. Okay. 1 is equal to 1. You can find M. Or you can find N. So W as a N. So W as a N. What happens? So 1. One symbol means 1. Okay. Magnitude of this N is equal to 1. So the magnitude of the M is also equal to 1. If it is a Mn, the magnitude of it is equal to, you can write 2. Okay. So magnitude of the N single symbol, it is a 1. So even M also equal. So 1 mod 3 is equal to 1. We know that 1 mod 3 is equal to 1, and 1 mod 2, reminder is 1 mod 2. 1 mod 2 is also equal to 1. Okay. If you are dividing 1 by 2, 1 by 2, so you cannot divide, so therefore 1 will be the remainder. Even 3, so if you are dividing 1 by 3, so you cannot divide 1, so this will be the remainder. So there is a no quotient. For example, W div. W div 3 is there. For example, you can take W is a 1. W is a 1. It is a divisible by 3. So its answer is 0. Its answer is 0. Whereas a div, it is a reminder. So for 1 mod 2 or 1 mod 3, the answer is 1. Hence, either it is a M or M. How about 2? So if it is a 2, W is a 2. So for example, you can take Mn or Nm. Mn or Nm. So Mn or Nm is, its magnitude is equal to 2. Substitute here W as a 2. W as a 2, its magnitude. W as a 2. W as a Mn. W as a Mn. So what happens? So it is a 2. 2 mod 3 is what? 2 mod 3 is 2. 2 mod 3 is reminder. So 2 mod 3 is equal to 2. And 2 mod 2 is equal to 2 mod 2 is equal to 0. Okay. 2 is 2 is equal to 0. So no, 2 is not equal to 0. Therefore, you cannot take these two strings. These two strings you cannot take. Even you cannot take MMM. MMM is 3. You cannot take NNN because 3 mod 3. So 3 mod 3 is this will be 0 and this will be 1. 3 mod, what is the answer for 3 mod 2? 3 mod 2 is equal to 3 mod 2 is equal to, it is 1. 3 mod 2 is equal to 1. Why? Because, so if you are dividing 2 by 3, so 3 by 2, the answer is 2 1 2. So the remainder will be 1. That's what 3 mod 2 is, remainder is 1. 3 mod 2 is equal to remainder. This is the remainder. It will produce the remainder, hence it is equal to 1. So 3 mod 2 is equal to 1 and 3 mod 3 is equal to 0. Therefore, these two are not equal. Hence, even 3 also not possible. 3 also not possible. L is equal to, so you can take epsilon, you can take single symbol, either M you can take or you can take N, not double symbol. How about triple symbol? Triple symbol is also not possible. How about 4? So 4 mod 3 is what? 4 mod 3 is, what is the value for 4 mod 3? It is a 1. Whereas 4 mod 2 is equal to 0. 4 mod 2 is equal to 0 because it is not producing the remainder. Hence, 1 is not equal to 0. You cannot take even 4 symbols also. So 5 symbols. So 5 mod 3 is equal to 2. Remainder. So 5, if you are dividing by 3, 3 1 ja 3. So remainder is 2. Therefore, 5 mod 3 is equal to 2. And 2 mod 5 mod 2, 5 mod 2 is equal to 1. Therefore, so 2 is equal to 1, 2 is equal to 1, it is a wrong. Even 5 is also not possible. How about 6? So 6 is in the case of the 6, 6 mod 3, 6 mod 3 is equal to 0 and 2 mod 6 mod 2 is also equal to 0. 6 mod 2 is also equal to 0. You can take the string called as a MMM. 6. 6 you can take. 6M or you can take 6N. 6N fulfill the condition. What is the condition? So W mod, magnitude of the W mod 3 is, it should be equal to the W mod 2. So 6 fulfill the condition. How about 7? 7 M's, or you can write. Or you can write M, N, M, N, M, N. Or you can write N, M, 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 N, 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 M, N. Okay. So any string which consists of the 6 alphabets, it is accepted over the sigma is equal to M comma N. it is accepting. Okay. 7. So 7 mod 3 is what? Just check it. 7 mod 3. 7 mod 3 is equal to 1. Okay. If you are dividing 7 by 3, 7 by 3, so it is a 3 2 is a 3, 6. So the remainder is 1. Therefore, 7 mod 3 is equal to 1. And 7 mod 2. 7 mod 2 is equal to, it is also 1. Hence, W may be 7 symbols. Okay. MM, MM, MN, N. So like that. It may be a 7 symbols. It may be 7 symbols. Therefore, the DFA for such a finite automata is either it has to accept the epsilon. Epsilon means initial state is the final state. It is accept initial state is the final state. It has to accept the either single M or single N. So this is the finite automata which is accepting. M comes, it is accepting. N comes, it is accepting. It should not accept 2M or 2N. 2M and 2N should not be accepted. That's what it is, a non-finite state. It is a non-finite state. For example, initial, you can take MM is not accepting. MM is not accepting. And two M's are there. Its value is 2. And 2M mod 3 is equal to 2M mod 2? No. So in the case of the mod 3, it is answer is 2. In case of mod 2, it answer is 0. Hence, 2 M's are not accepted. Even 3 M's also not accepted. That's what M comma N. So this is also non-finite state. So 4 M's or 4 N should not be accepted. So that's what it is, M comma N. Even it is not accepting 5M and 5N. So it is not accepting. But it is accepting, see, 5M, 2M's are not accepting. Okay. 1M or 1N is accepting. Even epsilon is accepting. So 6M comes, it should accept. That's what I am taking it to the here. So it is 6M here, 6N is coming, or combinations. 6 symbols are there, it should accept. Whether it is all M or all N or combinations of the MN, now it is accepting. For example, you can take 6 string symbol, 6 symbol string like a M, N, N, M, 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 6 symbol. First M it is to this, next N is to the this, next N is there to the this, next M is to this, M is to the this, next last one M is there. That's what it is taking to the point state. Even you can find 7M. 7 M's is accepting. First one, second one, third one, fourth one, fifth one, sixth one, seventh one. This is the seventh one. So seventh is accepting. You can take the 12 ones, 12 strings symbol, 12 string symbol, 12 symbol strings. Okay, if the string consists of the 12 symbols, so in that case also it is accepting. The string consists of the 13 symbol also, whether all are M or all are N or combinations of the MN. So 13 symbol strings also accepted. 13 symbol strings also accepted. Even if you take 18 is accepting. 18 means, so it is almost 3 times in the loop. 19 is accepting, but 20 is not accepted because 20 mod 3. See, you can take 20 mod 3. 20 mod 3 is equal to, what is the answer? 2. 20 mod 3 is, it is a 2, and 20 mod 2 is equal to 0. 20 mod 2 is equal to 0. Therefore, 2 is equal to 0, so condition false. Hence, 20 should not be accepted. It is not accepting. 18 means it will come to this, 19 to the this one, 19 to the this one, and 20th to the, again it is to the non-final state. Non-final state. Now it is not accepting. It is accepting only the condition which is fulfilled by mod 3 and mod 2. For example, you can take the language L. Very important question. The language L. L is equal to W. L is equal to W. The condition given mod W, magnitude of the W mod 3 not equal to the magnitude of the W mod 2. W mod 2 over the symbols, over the symbols, over the symbols or alphabet, or the symbol sigma is equal to x comma y star. Okay. Hence, description of the language. What is the language here? Epsilon. Epsilon 0 is not possible. Okay. 0 is not possible. What about 1? 1 is also not possible. 2 is fulfilling condition. 2 is fulfilling condition because 2 mod 3 is equal to 2 and 2 mod 2 is equal to 0. 2 mod 2 is equal to 0. Therefore, 2 is not equal to 0. 2 is not equal to 0. Hence, 2 symbols is accepted. Maybe a double x, xy, okay, yy, or yx is accepted. Yx is accepted. 2 is accepted. How about 3? 3 mod 3 is 0 and 3 mod 2 is 1. So even 3 symbol string is also accepted. 3 symbol strings, maybe XX, YY or combinations, XXY, like that you can find. So it is accepting 4 symbol strings. For example, fulfilling condition 4x. So 4x means it is a 4. 4 mod 3 is 1 and 4 mod 2 is 0. 4 mod 2 is 0. Hence 4x is also accepted. 4y is accepted because this y is equal to, it is a 4. Even combinations is accepted. X, Y, YX is accepted. String made up of the 4 symbols, either the X or Y. X or Y. 5. So 5 mod 3 is, 5 mod 3 is, it is equal to 2. So 5 mod 2 is equal to, it is equal to 1. Therefore, 2 is not equal to 1. Again, the 5 is also accepted. So you can take all 5x, all 5x should be accepted, all 5y should be accepted, or combinations xy, yx, so like that 5 symbols accepted. How about 6? So 6 mod 3 is, so it is a 0. 6 mod 2 is also equal to 0. 6 symbols should not be accepted. Even 7 symbols, 7 mod 3 is equal to 1. Even 7 mod 2 is equal to, it is also equal to 1. 7 symbols should not be accepted. Therefore, the PDA is, it should accept double symbol string. So hence what I am going to do, epsilon is not there. So double symbol string should be accepted. X comma Y, single symbol should not accept. Doubles it should accept. That's what. String is made up of only 2x, so it is accepting. String is made up of xy, so xy is, it is equal to 2. It is equal to 2. Hence it should be accepted. That's what. The third state is a final state. So initial state is not a final state because there is no epsilon. Epsilon is not there in the language. 2x or 2y's are there. It should accept. 3x or 3y should be accepted. That's what. The fourth state is also a final state. So 5 symbols also accepted. That's what. The even fifth state also a final state. So it is accepting the 5 symbols. So sixth state is also a final state. Sixth state is also final state. 6 should not be accepted. 6x or 6y should not be accepted. That is what it is not accepting. X comma y is not accepting. Even it should not accept 7 x or 7 y's or 7 combinations of the x and y. It should not be accepted. For example, first x, second x, third x, fourth x, fifth x, sixth x, 7x is not accepting. 7x is not accepting. So this is the PDA. Sorry, this is the DFA. This is the DFA which accept W mod 3 is not equal to the magnitude of the W mod 2. W mod 2 over the symbols x comma y. This is the DFA for the language. L is equal to W, where W is W mod 3 is not equal to W mod 2.